All right, this is section 4.2 about polynomial functions and models. All right, so first remember what a polynomial function looks like. Let me zoom in here. So we said previously, in the previous chapter, we said a polynomial function is of the form f of x equals a sub n x to the nth plus a sub n minus 1 x to the nth minus 1 plus a sub n minus 2 x to the n minus 2, and of course you keep going, right, plus, and really what you're keeping going is that you're subtracting 1 from the exponent each time, okay, until you get to whatever, right, you might get to an x squared plus a sub 1x plus a sub 0, okay, and so at that time we might have mentioned that there were various things we've seen already that qualify, like these, right? Specifically the quadratic, I think I mentioned before, is of that form, but it only covers the last three terms. Yeah, and the coefficients are just named differently, right? So here, over here I call them a, b, and c. Up here I call them a sub 2, a sub 1, a sub 0. Okay, but otherwise it's the same thing. All right, so we're going to look at some trends of these polynomial functions, and notice they're given special names. And you want to know the special names because if you just call them polynomial functions, well, this is a polynomial function, this is a polynomial function, this is a polynomial, but you don't really get the details. Whereas if I say quadratic function, then that in your head you have to be thinking, oh, that's a parabola, right? Which way is it pointing? We don't know, but it's a parabola, right? If we look at a linear function, we know that's in the shape of a line. Yeah. All right. So let's take a look at the degrees. Remember, the degree is the exponent, and it's the highest exponent showing. So this is degree n minus 1, right? Just whichever one is the highest that you see showing. So, for example, if we have a quadratic, the degree, the highest degree showing, the highest exponent showing is 2. The degree is 2. If we only have from there on, the highest degree is 1. So the highest exponent is 1, so the degree is 1. If we only have an a sub 0, then there is no x, but if we can think of it as x to the 0 power, and therefore the degree will be 0. So the degree here is 0. Maximum number of x-intercepts, well, a cannot be 0, remember. So if it's like f of x equals 1 or negative 3, remember this is like y equals 1 or y equals negative 3. Be less than 0 would be like y equals negative 1 would be something like this, right? And for greater than 0, that's like saying y equals 3, so it'd be something like that. Okay, how many x-intercepts can a flat line have? None. How many turning points can it have? None. All right, let's take a look at the second one. F of x equals ax plus b. Remember, this is like y equals mx plus b. It's a line with some slope, which means it's slanting up or it's slanting downward. The degree is whatever the exponent of the highest one you see there, 1. Turning points, no, it doesn't turn. It's a straight line. Intercepts, I'm sorry. Intercepts, not, it can have intercepts. It can x-intercepts. It can have one x-intercept, right? Turning point 0. And then how does it look when a is less than 0? That means when the slope is negative, well, it's going downward that way, okay? And when the slope is positive, well, it's going upward that way. All right, let's take a look at the quadratic formula. And again, these are ones we've seen before. The degree is 2, right? That's the highest exponent we see there. Number of x-intercepts, well, 2, right? Because wherever your x-axis is, your parabola can cross it twice, regardless of which direction it's pointing. Number of turning points, well, it only has 1, right? If it's going upward first, then it turns, and then it doesn't turn again. It only has one turning point. How about it next to the third? Well, its degree is 3. And how many x-intercepts? Well, the way you want to think about it is, if you look at the quadratic, and just think of it in factored form. So a quadratic in factored form looks kind of like maybe 2x plus 1 times x minus 1, something like that, right? So you see two factors, and then if you remember, we solved when we had 0 equals some quadratic, so we would say 0 equals 2x plus 1 times x minus 1, and then we would say, okay, 2x plus 1 equals 0, so we could find the values of x. And if you have two factors, well, you get two x-intercepts. And this one, if you have three factors, like x plus 1 times x plus 2 times x plus 3, that would be a cubic function. Well, you could have three x-intercepts because you could find three values of x. How many turning points? Well, you got to have one more, right? Because if you're starting, let's say, upward, and you cross the x-axis once, that's one x-intercept. Then you have a turning point, that's one turning point. And then you have another x-intercept. So you have two x-intercepts with one turning point. And then another turning point, that'll give you three. I forgot to draw the this one up here. I was just noticing the parabola. All right, so for let's go back to the parabola. So when a is less than 0, so with negative leading coefficient, that means your parabola is upside down. Doesn't matter where the vertex is, parabola is upside down. Okay, and if it's a greater than 0, parabola is smiling or pointing upwards. All right, how about this one, and x to the third power? So that one, remember, you can have three x-intercepts. So you actually start from the left bottom and go upward. That's one x-intercept, two x-intercepts, three x-intercepts. Okay. And then if it's I'm sorry, this is a. Oops, sorry about that. So a less than 0 is actually the other way around. It goes the other way. 1, 2, 3. All right. Oh, well, we're gonna have to figure that out, right? How do we know? And a greater than 0 is actually the other one that I had drawn. It goes up that way. Okay, notice very similar, but one's kind of going from downward as we go to the right, and one's going upward as we go to the right. Kind of like the line, right? It goes downward to the right or upward to the right. Okay, we'll come back to that. And x to the fourth power, well, the degree is 4, and x-intercepts, well, again, if we think about in factored form, we'd have to have 4 factors, so that would give us 4 x-intercepts. How many turning points? Well, look at the relationship between x-intercepts and turning points, right? Look at the relationship, yeah? Okay. All right. And what does this one look like? Well, this one actually starts kind of like a parabola. So when a is less than 0, it actually starts over here, and then you have one x-intercept, two x-intercepts, three x-intercepts, four x-intercepts. It might look like an M, but it doesn't have to. If a is greater than 0, it just flips around. So one x-intercept, two x-intercepts, three x-intercepts, four x-intercepts. All right. Does it have to have 4 x-intercepts? It turns out it doesn't. Yeah, and we'll discuss that a little bit further in class. All right. And x to the fifth, I'm going to leave this one blank. I'll leave it blank. See if we can fill it in later. Okay. And the next two parts, the degree n and that part too. Okay. So let's look at the end behavior of the graph of a polynomial. So we've actually seen the end behavior, by the way. The end behavior means what happens as you're going to the left at this end. Notice there's a left end and a right end. A left end and a right end. A left end and a right end. For all of them. Where's my left end here? Left end, right end. Left end, right end, right? Left end, right end. Left end, right end. Okay. Except we don't say left or right. I don't know if you notice right here. There's no left or right. No mention of it. Okay. So for even degrees, that means quadratic or quartic. Those are even degrees. If a is greater than 0, right, for the quartic or quartic or quadratic, if a is greater than 0, that's this column. This says here f of x approaches infinity or goes to infinity as x approaches negative infinity or as x goes to negative infinity. What does that mean, x goes to negative infinity? It means the left. Remember we said the left end and the right end? That means on the left end, y goes positive or y goes up. So for even degree, that means for a parabola, a greater than 0, on the left, y goes up. On the right, y goes up. How do we say on the right? Y goes up as x approaches positive infinity. That means on the right, okay? But notice how we say it, right? Y goes up, we say f of x goes to positive infinity. To the left, we say as x goes to negative infinity. And on the other hand, f of x goes to positive infinity. It means goes up as x goes to the positive infinity, which is the right-hand side. Let's read one more, and then we'll leave the rest for another video. So a is less than 0, that means the other way around. F of x goes to negative infinity as x goes to negative infinity. It means on the left. F of x goes to positive infinity, to negative infinity, I'm sorry, as x goes to positive infinity. It means as you're going to the right, this is going downward. Notice the translation, right, and how you have to write it. All right, for odd degrees, for a is greater than 0, odd degrees would be like this one and this one. F of x approaches negative infinity as x goes to negative infinity. It means on the left, I'm sorry, for a greater than 0, so it's this one. F of x approaches negative infinity as you go to negative infinity, and f of x approaches positive infinity as x goes to positive infinity. It means to the right. Okay? All right, and a less than 0, f of x goes to positive infinity as x goes to negative infinity. That's this one. And f of x goes to negative infinity as x goes to positive infinity. All right, I'm going to stop this video there, and then we'll look at these examples and see how do we figure this out, the degree and leading coefficient and the end behavior. Okay, let me stop this part here.